Example 3.12. In this example, we have water flowing under a sluice gate as shown. We need to determine the approximate flow rate per unit width of the channel. To start the analysis, we're going to write the information that we have from the graph. We know that the elevation of the reservoir is equal to 5 meters. That is labeled as Z1. The width is going to be 6 meters. That's written as B. And the height of the exit is equal to A. Now we need to determine what is the effect that vena contracta is going to have in this particular flow. In order to determine that, we need to obtain the ratio between A and Z1 and see whether it's within the validity for the use of the contraction. So the validity is evaluated as such that the ratio between A and Z1 has to be between 0 and 0.2. So we're going to take the value that we have. The value that we have is 0.8 divided by 5. And this value is equal to 0.16, which is within the range desired. That allows us to use vena contracta to evaluate the effect that this geometry is going to have. Notice that this is a rectangular cross-sectional area, therefore the coefficient that we could use is going to be 0.61. With that information, we could find out what is the actual value of Z2. So we know that the value of Z2 is going to be equal to the coefficient for vena contracta and the elevation that we have for the hole. So we could find that the value of Z2 is equal to 0.488 meters. Now what we are going to do is we're going to calculate the value of Q using both of the methods, one without the approximation and one with the approximation. So let's start with without the approximation. So we know that the value of Q and it's by unit width, so we have Q divided by B, and that is equal to Z2 square root of 2G Z1 minus Z2 divided by 1 minus Z2 Z1 to the second power. If we take these values, we could find that the ratio between Q and B is equal to 4.61 meters per second. If we do the same analysis with the approximation, the equation that we could use is Q divided by B is equal to Z2 to G Z1. And we find that this value for this approximation is equal to 4.83 meters square per second. Notice that the value within the approximation and the correct value are similar to each other. Note that you could use the approximation only in the case that Z1 is greater than Z2. Usually you want to have it at least 10 times bigger to be able to use this approximation.